So this is a second video on the practice test. Still on page 1, let's move on to question 3. On the previous video, we did all the equations that had fractions on the front page. Now let's move on to a multi-step equation that requires simplification. Again, the goal to solve any equation is to get m by itself on one side of the equal sign. Problem is you have m's on both sides. Not only that, the first step to solving any equation or any math problem really is to make it more simple, to simplify it. Now, what does simplify actually mean? It means distributive property and combining like terms. Okay, so we're going to simplify each side, one side at a time. And again, simplify means distributive property and combining like terms. So let's start with the left side. Now, just for the sake of us ignoring the right side, I'm going to put that rectangle over it so we don't even worry about it. On the left side of the equal sign, we are going to distribute. Now, because it's a -5, I like circling it and then drawing some arrows. -5 times 3, that's -15. -5 times -m, that's a positive 5m. And of course, after we distribute, we bring down everything else, the +4. Now, after distributive property, what's next? Combining like terms, right? Combining like terms. So we're going to combine the 15, the number -15, with the number +4. If you owe $15 and you have $4, you're going to owe $11. Actually, let me do this in black. You owe $11. Let's bring down the +5m. And of course, that is all you could do. You cannot simplify further because you've already distributed, you've already combined like terms. You can't really, -11 plus 5m, you can't do that because the terms are not alike. These are m's, these are numbers. It's like saying I have 5 monkeys, let's take away 11 apples. You don't have apples, these are monkeys, right? So that's as simple as it gets. So you simplified the left side, now let's simplify the right side. That is step 1 on any equation, simplifying it one side at a time. On the right side, again, we're going to distribute first. 4 times m, that is 4m. 4 times -2, that's -8. And of course, we're going to bring down the +m and also the -3. So we've already distributed. Now there's 4 terms here. We're going to move on to combining like terms, the terms that are alike. So monkeys with monkeys, and then numbers with numbers, right? M's with m's, and then the numbers with the numbers. So 4m plus 1m, that is a total of 5 m's. Let me keep it in black over here, 5 m's. And then we have this -8 that I want to combine with the -3. You owe 8, you owe 3, you're going to owe 11 altogether. Now, once again, let me remove this rectangle. What do we have here? We have a new equation. We simplified the left side, simplified the right side. The equal sign, notice, the equal sign should come straight down. This is the way to stay organized, guys, to just bring down your equal sign and stay. You could even, like I've mentioned before, you could even draw like a squiggly line separating your left side and your right side. Because if you start drawing your equal sign over here and it's not lined up, you might get confused with your own work. Anyhow, let's continue. Now that it's a simplified equation, we want to get m by itself on one side. Now, where's the m at? Is it on the left side of the equal sign or the right side of the equal sign? So we could get it by itself over there. Well, the problem is that it's on both sides. You don't want it on both sides, so we need to get rid of one of them, right? Whenever you don't want something, you get rid of it by doing the opposite. So let's say I didn't want this 5m over here. Let's say I only wanted m's on the left side, so I wanted to get rid of this particular 5m. So how do I get rid of 5m? You simply take it away. 5m, take away 5m is 0 m's. It'll cancel out. It'll not be there anymore. But it's off balance. What you do to one side, you do to the other side. So you're going to subtract 5m over here. And the problem is that 5m take away 5m also cancels out. I know that's really weird. That's because this is a special case equation. What's left over? Well, on the left side, I have a -11. Let me bring that down. The equal sign obviously comes down always. And over here, I also have a -11. So what do you guys think? -11, does it equal -11? Yes or no? Of course, yes. If it were like -10 equals -11, then you would say no, as in no solution. But right here, yes, it's -11 is always equal to -11. It's always equal to itself. So whenever you have something that's always true, you say all real numbers. Now normally you would say x equals all real numbers, but in this case we're solving for m, so m equals all real numbers. This is your answer, m equals all real numbers. What does that mean? It means that your m value could be any real number you want, as long as you plug in that same real number into all the m positions. So if you say m is 5, if you plug in a 5 right here, a 5 right there, and a 5 right there, and you do all the math on the left side, it will equal everything on the right side. It'll be a true statement. Or even if you were to plug in a 0 right here, a 0 right there, and a 0 right there. Or you could even plug in a fraction like 1/2, 1/2, 1/2, or if you plugged in a pi right here, pi right there, pi right there, it will always be a true statement. As you could see, what happened in the work that we did, the m's eliminated. What does that mean? Well, it means that m doesn't really matter. It could be any number you want. You're always going to get a true statement. 11, negative 11 equals negative 11. So m could be any real number you want. Anyways, that was probably a little more explanation than what you needed. Let's move on to the next question. Number 4. Okay, this one is a simplified equation. What do I mean by it's a simplified equation? Let me use my rectangle. If I cover up the right side and I go, well, what about this left side? Is there anything I could do? Is there any simplification that I could do? And if you're thinking, well, what does he mean by simplify? Again, simplifying means distributive property and combining like terms. Anytime you think of simplification, the first step of solving any equation is to do distributive property and combining like terms on one side at a time. Do one side at a time. Don't try to do both. So on the left side, is there any distributive property? No. Is there any terms that you could combine that are alike? No. So the left side is already simplified. The right side is also already simplified. There is no distributive property. There's no combining like terms. So this is what we call a simplified equation, ladies and gentlemen. So now that it's simplified, we can move on to the goal of solving any equation. What's the goal? To get the variable by itself on one side of the equal sign. So where's the j at? Is the j on the left side of the equal sign or the right side of the equal sign? It's on both sides of the equal sign. You don't want j on both sides, right? You just want j on one side. So let's get rid of one of these j's. You could decide to get rid of this 3j if you want by doing a minus 3j, or you could decide to get rid of this minus 5j by doing a plus 5j. So it's up to you. There's many roads to the same place. The minus 5j, I'm going to get rid of it by doing the opposite, plus 5j. And that'll cancel out. Of course, what I do to one side, I do to the other, plus 5j. So the 3j minus, or plus 5j, that gives you 8j's total, right? So let's write that down. We have 8j's. The equal sign always comes straight down. That's how to stay organized. What's left over on the left side, in addition to the 8j, the 16. Of course, that's a positive 8j, so let's put a plus right in front of it. And what do we have left over on the right side? On the right side, we just have a regular 18. So guys, this is our new, easier equation that only has a j on the left side. So up here we had j's on both sides. Now we only have j on one side. Let's get that j by itself. Of course, I want to get rid of that 16 by doing the opposite, minus 16. What I do to one side, I must do to the other to maintain the balance. So what do I have left on the left side? Again, if you're confused, go ahead and draw a little wall. That way you could keep your left side separate from your right side when you're doing your work. Okay. So what do we have left on the left side? We have an 8j left. What do we have on the right side? Let's bring down the equal sign. On the right side, we have 18 take away 6, which is 2. Now, how do I get rid of 8 times j? How do I get rid of this multiplication of 8 in front of the j? Well, to get rid of something, you do the opposite. The opposite of multiplying by 8 is to divide by 8. And of course, what you do to one side, you do to the other side. Okay, so the 8's do cancel. Now, I don't know how many times I've explained this, but I keep seeing students make the mistake over and over again. For some reason, students see this problem and they say that the answer is 4. And like every time you do it, I want to like slap myself. Yes, because like I'm like, what am I doing wrong? The answer is not 4, guys. Okay, the fact is this. Top number is always being divided by the bottom number, right? Okay, so if it were 10 divided by 5, yeah, the answer would be 2. If it were 16 divided by 4, the answer would be 4. But what does it say here? It says 2 divided by 8. 2 divided by 8? You can't do that. If it were 8 divided by 2, you could do that. The answer would be 4. But it doesn't say 8 divided by 2. It says 2 divided by 8. You cannot divide 2 by 8. So That's your answer, the fraction 2 over 8. Okay, that's your answer, 2 over 8. Now, the problem is whenever you have a fraction as an answer, of course, you want to give the reduced fraction. You just don't want to leave it like this. So the question is, could you reduce 2 over 8 by anything? Yes, you could reduce by 2. So let's divide by 2, and you will have j equals 1 over 4. J equals 1/4. The answer is not 4, guys. The answer is 1/4. There's a big difference. Number 6. So step 1 to solving any equation is to simplify the equation. Make it simpler, right? What does simplify mean? Of course, you already know, distributive property and combining like terms. That's what it means, for you to distribute and then combine. Of course, you're going to do one side at a time. So obviously, if you were to cover up the left side and say, what could I do on the right side? Is there any distributive property? No. Is there any combining like terms? No, it's just one single term, 2n. So that's already simplified. It's very, very simple. There's nothing to do there. On this side, there's a lot of work to do, right? So all we have to do is simplify that left side. Again, distributive property first, and then combining like terms. So if you're thinking, oh, 5 plus 2 is 7, I want to write 7. Right? No, that's wrong. Okay, don't do this 5 plus 2. Distribute first. So you're going to go 2 times n, that's a positive 2n. 2 times 1, that is a positive 2. Bring down the 5 that's out here in the front. Bring down the equal sign. Bring down the 2 and the n. The 2n, bring it down. There's your new equation. But on the left side, you could still combine like terms. So we're going to combine the 5 with the 2. And what's 5 plus 2? It's 7. So what's my new left side of the equation? Remember, you have two sides to every equation, the left side and the right side. So right here on the left side, what do I have? I have a 7 plus 2n. Or you could write it 2n plus 7. Of course, the equal sign's still right here. The 2n is still right here. So here's our new equation, guys. 2n plus 7 equals 2n. There it is in black for you. Anyhow, we want to solve this thing. So you got to, choose the correct or the quickest path, I would say. So if you have a number over here, and if you were to move this 2n and get rid of it, then you'd have to move the number over here and get the n by itself. So I guess if you think about it for a couple of seconds, it's easier to move this 2n to get rid of it. That way you have n's on this side, and you could then get n by itself with the number on this side. This is going to be a special case anyway, because when I get rid of this 2n right here, I need to get rid of it by doing the opposite of 2n, which would be a negative 2n, subtracting 2n. Okay, so 2n take away 2n, that is 0n, so it's gone. But of course, what I do to one side, I must do to the other side. So take away 2n's over here. And strangely enough, 2n take away 2n, it also becomes 0n's. There are no n's. So what is left over on the left side? I have a 7 left over on the left side, equaling what's left over on the right side. Well, what is 2n? Take away 2n, it's nothing, it's 0. So this, I know you might be freaking out, thinking, wait a minute, 7 is not equal to 0. That's impossible. Exactly, 7 cannot be 0. So what do we say? We say no. Well, you don't just say no, that'd be weird. You have to say no solution. This is your correct answer. By the way, the symbol for no solution is a little 0 with a slash right through it. Okay. But anyways, what does no solution mean? It means that there is no number. It does not exist. You can't plug in any number in here and here that'll make this a true statement. It just doesn't work, right? 7 will never equal 0. So this is a special case problem as well. Let's move on to the second page on the next video, that is. So on this video, we covered a couple of questions, 3 questions, and 2 of those 3 were special cases. This one was all real numbers, this one was no solution. Again, just to review or reiterate special cases, when you end up with something that's always true, negative 11 equals negative 11, or 0 equals 0, or 5 equals 5, when it's always true, you say all real numbers, okay? When you end up with something impossible, like 0 equals 7, that's impossible. What do we say? We say no, as in no solution. We'll pick up the second page on the next video.